Hi everyone, welcome back. Very good evening to you all. So myself Ayush Tripathi, DSA mentor and problem setter at Geeks, and welcome you all to this post analysis of last Bivizard weekly contest. Not a weekly contest, but a monthly contest. Sorry for that. So just allow me 1 minute. So can someone just please confirm if I am audible? Or let me just quickly check. Alright, so everything seems good to me. So starting with the very first problem, which is the most frequent, named as the most frequent. So you are given an array of size n. All right, let me just also share the screen. Sometimes I feel there has to be someone who can check the connectivity and all these things. Anyway, so yeah, I hope the screen is visible to you. So starting with the first problem, given an array of size n, and our task is to report the most frequent element of A. And if there are more than one most frequent element, then we have to return the largest one, right? So a pretty standard problem and a very easy problem. So what we can do, we can store the frequency of every element. Let me just quickly take this example. So what you can do, you can use a map data structure. This is the one solution. No doubt there exist more solution. You can also sort the array and then count the frequency. That would also work fine. But I will discuss the solution in which I have used a map data structure. So let me just quickly paste the example here. So what I will do, I will use a map of int comma int, where key is integer is of integer data type and the value is also of integer data type, right? So then we'll iterate over the entire array. So for I is equal to 0, or what else I can do, I can use a for each loop, right? So for x in A, right? And then I will increment the frequency of x in this map, basically the value corresponding to key x, so which is mp of x plus plus, and then iterate over this map and find the maximum frequency. Or let me just quickly dry run. So mp of 1, previously it was 0, now it has been incremented to 1, right? Currently we are at this element 1, and then we'll move to the next element 2. So we'll increment the frequency of 2. So previously it was 0, and now it has been incremented to 1. Then 3. So mp of 3 is equal to 1. Previously it was 0, now it is equal to 1. Then 4. So mp of 4 is equal to 1. And then next element, again we got 4. So now the frequency of 4 is 1. So we'll increment it. Now it is equal to 2, right? and then 1. Previously it was 1. Now we'll increment it to 2, then 2. The frequency of 2 is 1, now incremented to 2, right? So then iterate over this map, and find the maximum frequency. So what is the maximum frequency? So max frequency is 2, right? Max frequency is 2. Then again iterate over this element, right? And if the current key is having frequency equal to the max frequency, then simply update your answer. So iterate over this map, and if the current key is having frequency equal to the maximum frequency, then update your answer, right? So let me show you the implementation here. So if I'm using a map, then incrementing the frequency of all the elements of A by 1 for every element, then finding the maximum frequency. So max is equal to 0, then iterating over this iterating over the map, and max is equal to max of max, that is the frequency that we have, maximum frequency that we have encountered so far, comma the frequency of the current element, right? Current key. So the frequency of the current key is I dot second. Then we'll update this map accordingly, and then initializing the answer with some default integer. It can be -1 or something. And then again I'm iterating over this map, right? And checking if the current key is having frequency equal to the maximum frequency, then we'll update our answer, right? And why I'm updating our answer? Why I'm not taking maximum of answer comma I dot first? Because we know the property of map. It is a map, right? It is stored the keys in ascending order, right? So that's why we are moving in ascending order, smaller values of key to the bigger values of key, and then we'll simply return our answer. And the time complexity of this solution is n log n, since we are using a map, and the space complexity is linear O of n. So hope it is clear to everyone. So write a +1 if it is clear to you. Yes, no, anything. Write a +1 if it is clear to you. All right, so let's just solve the next problem. So equalize sticks. So given n sticks with a different length, and the length of the ith stick is length of I given by this length array, right? And you can either increase the length of the stick, or you can decrease it, and an array of cost will be provided to you, where cost of I is assigned to the cost of increasing or decreasing the length of ith stick by 1 unit, right? Basically cost of I denotes that the cost, or basically the amount that you need to pay to increment or decrement the length of the ith stick by one unit. And our goal is to make all the stick of equal length, and ensuring that the cost would be minimum, right? And we need to return that minimum in occurred cost. So for this example, the best way is to increment the length of first stick by 2 unit, then the cost would be 20, right? Because the cost of increasing or decreasing the length by 1 unit is 10, right? And we have decided to increment the cost of the we have decided to increment the length of the first stick by 2 unit, so the cost would be 10 into 2, which is 20. And then the length of the first stick is now 3, right? Which is equal to the third one. And then increment the length of the second stick by 1 unit, then the cost would be 2 into 1, which is 2, right? So now all the stick has the length 3, right? And basically all the stick are having now equal length, and the cost is 2 into 10 plus 1 into 2, which is 22. And this is the minimum cost that you can achieve. So is the problem statement clear to everyone? I guess I forgot to share the screen. Let me just quickly again read the problem statement. So you are given n stick with a different length, and the length of the ith stick is length of I, and you can either increase the length of the stick, or you can decrease the length of the stick. And the array of cost will be also given to you, where cost of I denote the cost of increasing or decreasing the length of the ith stick by 1 unit. And we need to make all the stick of equal length, ensuring that the was in minimum cost was incurred, right? So for example, this one, So let me just quickly copy this example. So the best way to increment the length of the first stick by 2 unit, and so now its length become 3, and increment the length of the second stick by 1 unit, so it is now 3. All the stick has equal length, right? And what is the cost occurred? We have incremented the length of the first stick by 2 unit, so 10 into 2, right? This 10 is the cost of incrementing or decrementing the first stick by 1 unit, and we have decided to increment the cost of first stick by 2 units, so that's why 10 into 2 and plus 2 into 1, which is equal to 22, and 22 is the minimum answer that you can achieve, and it has been proved. So yeah, 22, same as the expected output. Now how we can solve this problem? Anyone? Any approach? How we can solve this problem? So write a plus one if the problem statement is clear to you, or a minus one so that I can explain it again. What is the condition of decreasing the length? Okay, there is no condition. Basically, at the end, you want to make all the. So at the end, what we want all the stick to be of the same length, right? So there is no condition with that. The cost, the cost, you can either decrement the length of the stick by 1 unit, or you can increment the length of the stick by 1 unit. Both has the same cost. So how we can solve this problem? So let's just quickly draw some observations. And the best way to solve this problem is to observe the pattern by drawing the bar. So the very first thing that I will do, I will sort all these sticks in ascending order of their length. So let's say the first stick, then the second one, and the third one, and let me draw two more sticks here, the fourth one. I have sorted all these sticks in ascending order of their length. So one very basic reasoning that came to your that is very obvious, that at the end what we want, and now please try to pay more attention here. At the end, what we want all the stick to be of the same length, right? So what I will do, I will convert all the stick to some particular stick, right? So basically, first I will try to convert all the stick to this stick, length of this stick, and how I can convert this to the length of this stick. I can simply use the decrement operation, right? I will decrement the length of these sticks, right? And then we'll check what is the cost to convert all the stick to this one, right? We increment the length of the first stick, and we'll decrement the length of these stick, right? Then we'll check for the third one, then the fourth one, and the fifth one, right? And my answer will be the minimum out of these five possibilities for this example. And some of you might wondering that prove me that at the end we want the length. The best answer is having the length among one of these stick. So you can prove this thing by a principle of induction, right? And I will not go into that thing, but it is a pretty standard problem. What I will do, I will first iterate over this stick, right? And first I will find what is the cost. What is the cost to convert all this stick to this one? So let me also write some example, real life example here. Let's say the length 5 and the length 10, then maybe 12 and 12 and let's say 15. And also we'll write a cost here. So the cost, let's say the cost is what we can say. Let's say the cost is also 10, 20, then again maybe 20, then again 10, and let's say 5, or maybe it should be greater than this one, right? We have sorted in ascending order. So I can write this thing as 15, and let's say the cost is the cost is maybe 30. So for every stick, I will find what is the cost of converting all the remaining sticks to this length, right? And then we'll take the minimum out of these five possibilities. And how to do that thing? So for that, the n square solution is very straightforward. For every stick, iterate over all the stick on the left side and iterate over all the stick on the right side, right? And calculate the difference. Calculate the cost of converting the sticks on the left side to the length of the ith stick, right? And once you get this thing, get this thing, then you can find the total cost, and then take the minimum out of all the five possible stick, right? But the n square solution is bit slow and would give you a time limit exceed vertex. So you have to do something better, right? Here the value of n can be up to 10 power 5. So n square is 10 power 10, and that would give you a time limit exceed vertex. So you have to do something better. And what is that something better? So we'll draw some observation. So let's say the idea here is to use a prefix and suffix array, and let's say I know what is the cost of converting all these things. Let's just only focus on this left part, don't focus on this right part. So let's say I know this answer. What is the cost of converting all these stick which is on the left of it to this length? And so what is the answer for this? What is the cost of converting all the stick on the left of it to this length? Basically 12. So this is nothing but the sum of the length, right? Sum of the length multiplied by sum of the length multiplied by the current difference, right? Multiplied by the current difference. I have converted all the sticks. I have converted all the sticks to this one. Now, now I wanted to convert all the stick to this third stick. So this would nothing but this answer one, right? And plus what? The sum of the stick length. So this is length of 2 plus length of 1, right? Basically it is 1, stick 1, stick 2, stick 3 and stick 4, right? And multiplied by this thing, the current difference. So multiplied by the length of 3 minus a length of 2, right? This is the answer for answer 2. So answer 2 is equal to answer 1 plus basically the cost of converting all the string all the stick to length of the second stick plus the cost of converting all these sticks to the length of the third stick. So you can use this formula, plus length of minus length of 2. This is the formula, right? So what I can see here, Our answer depends on the prefix, right? Basically, we first need to calculate the answer 1 to find the answer 2, right? So this is the idea. I start iterating from left to right and calculate this prefix array and then calculate this suffix array. So prefix of I will store cost of converting all the sticks from 1 to I minus 1 to length of I. And similarly we can find the suffix array. So suffix of I will store cost of converting all the stick from index I plus 1 to n to length of I, right? Using the same idea, you can find the suffix array, and then iterate over the sticks from 1 to n. So we'll iterate over the sticks from 1 to n, right? We have n sticks, and here I denotes the index of the stick, and your answer would be equal to minimum of answer comma prefix of I, right? The cost of converting all the sticks in the left of it to I, length I, and plus suffix of I, the cost of converting all the sticks on the right of it to length I. So is it clear to everyone? This is the entire approach. Right or plus one if it is clear to you, or a minus one. Right or plus one if it is clear to you. A very straightforward statement. Let me explain it to you for the last time. So let's say you have this answer. The cost of converting all the stick in the left of it to length of the second stick, right? And to compute the cost of converting all the stick to the length of the third stick is nothing but the cost of converting all the stick, right? The cost of converting all the stick to the length of the second stick, which is answer 1, plus the length of all the stick in the left of it multiplied by the current difference. Because I know I have converted everything. I know I have converted, or what I can do. All right, so this is not the formula. I guess sorry, it's my bad. So now what I know, I have converted all the stick to length of the second stick, plus now I have decided to convert all the stick, right, to the length of the third stick. So this is nothing but all the previous cost. So cost of 2 plus cost of 1 and multiplied by the current difference, right? I know what is the answer to convert all the stick to this length, right? And now now I have decided. I know what is the cost of converting all the stick to this length of the second stick. Now I have decided to calculate this thing. So this is nothing but the cost of all the previous sticks multiplied by the current difference. So this is nothing but the current difference. So length of 3 minus a length of 2. So this is the current difference, right? So current difference. So is it clear to everyone now? So let me show you the implementation here. So initializing answer with a very large values, and then here I have this a 2D vector 2D vector of array where every element is an array. Then I am adding this length of I, comma cost of I, and then sorting this in ascending order of their length. Then vector A for prefix and vector B for suffix. Then initializing current with 0, and here current will store the cost of converting all these things to the ith stick, and then the sum, right? Basically for this I wanted to know what is the cost for every ith string. I wanted to know the previous cost of sticks. Basically cost of for every stick I, what I want to know. So I wanted to know the prefix of I minus 1, right? The cost of converting all these stick to length of the stick I minus 1, and and what is the next thing? I wanted to know cost of 1 plus cost of 2, and so on till cost of I minus 1, right? So this is nothing but I will store this thing in my sum variable as per my implementation. So we'll store this thing in a sum variable, and I will store this thing in the current variable. So don't get confused here. So then updating the current, right? So current plus equal to current difference multiplied by the cost, basically the sum. Then initializing this value to a of I, and then incrementing the sum to move to the next stick, and then again initializing this, updating this current. Basically then we are calculating the suffix array, and then iterating over all these sticks, and answer is equal to minimum of answer. So yeah, if answer is greater than the cost of converting all this stick to length of the ith stick, then update the answer, and finally return the answer. And the time complexity is of this solution is n log n, as we are sorting the array. So got submitted. Is it clear to everyone? Write a +1 if it is clear to you. What about other participants? If it is not clear to you, write a -1. Which part is not clear to you? So then the third problem, which is yet another string problem. Let me check how many submissions are there. So 30 submissions, totally fine. So you are given a string of length n. You are given a string of length n consisting of a opening bracket, closing bracket, and this question mark, this question character, and we can replace every question mark character with either opening bracket or a closing bracket. And here the definition of the valid string: a string is a valid if for every opening bracket we have its corresponding closing bracket in its right, and for every closing bracket we should have one corresponding opening bracket in the left. For example, this is the valid string, this one is also a valid string, and empty string is also a valid string, while this one is not a valid string, because for this opening bracket, for this closing bracket, we do not have any opening bracket in the left of it, right? And the same goes for here as well. Let me explain it to you, the valid string definition. So for example, valid string. So for every opening bracket, you should have a closing bracket in corresponding closing bracket in its right, and for every closing bracket, you should have an opening bracket. So for example, this is a valid string. This one is also a valid string, while these two are valid string, while this one is invalid string, because for this closing bracket, we are not having any opening bracket in the left of it. And another example, so maybe this one, right? For this closing bracket, I have an opening bracket in the left of it, right? This one. But for this closing bracket, I do not have any opening bracket, so this is again invalid string. So we need to report the number of unique, yeah, so we need to report the mac the number of unique valid string that we can generate, right? And there is one more additional constraint. You are given an integer k, and your task is to find the total number of unique valid string that we can generate, such that the maximum length of the substring of of a string containing the same characters not more than k, right? You should not have either k more than k opening bracket or more than k consecutive closing bracket. And since the answer can be very large, so you have to return the answer under modulo 10 power 9 plus 7. So here is the definition of substring. I'm not going to explain you this thing. You can read it by your own. So now let's just see how we can solve this problem. So it's a pretty standard problem of our dynamic programming. For every, so see, we can only replace a question mark with either opening bracket or closing bracket, right? We do not allow to perform any operation if the character is not a question mark. So what are the additional constraints here? So yeah, it's a pretty standard problem of our dynamic programming. For every question mark, I will explore all the possibilities. I will try to place a question mark here, and then basically I will try to replace it with a opening bracket, and will also try to replace it with a closing bracket, right? And I have to check for a few things. The first one is the count, consecutive occurrences of the opening bracket that we have placed so far, and yeah, for every closing bracket, I should have an opening bracket in the left of it. So for that thing, what I can do, I can assign, I will use a variable count, right? And initialize this count with 0. And for when I place a opening bracket, I will increment count. So count plus plus, right? When I place a opening bracket, and when I place a closing bracket, I will decrement this count. So what does it mean? So if at any moment, what I will see, if at any moment I see that count is less than 0, then what does it mean? It means we are leading to some invalid string. And why is it so? Let me explain it to you. So for example, this invalid string. So let me explain first for a valid one. So for here, the value of count. So the count has been initialized with 0. For here, the value of count is 1. For here, the value of count is again 1, because for every opening bracket, we'll increment the count. Then for here, it is, so for here it is 2, right? And for here it is 1, right? Because previously it was 2, now we have decided to decrement it, right? Because it's an closing bracket, and for here it is 0, right? So this is a valid string, because we didn't get at any moment the value of count is equal to 0. So remember this case. Now let me explain you. So this is an valid string. Let me explain it. Let's explain you for invalid string. So for example, this one, this one, and this one. So what is the value of count? So the value of count here is 1. Here it is 0. And at here, what is the value of count? It is minus 1, because for every closing bracket we decrement the value of count, and here it is minus 1. That means the resultant string would be invalid, right? And it's making sense as well. For this closing bracket, we are not having any opening bracket in the left of it. So it's an invalid string. So we'll immediately return 0 to the recursive function, right? So this is one constraint, and another constraint that you need to keep track of the consecutive occurrences of the same character. So let's say I have these many opening bracket. So we'll keep track of the count. So as per my implementation, I'm using a variable p. So consecutive, that will store the consecutive occurrences of characters, right? And let's say here I have a question mark. So if here what is the value of p? So the value of p is equal to 4, right? The 4 consecutive occurrences of opening bracket. And when I make a call, when I change this question mark, when I change this question mark to opening bracket, then I will increment the value of p. So it is 5 now. So the value of p is equal to 5. And if I decided to change it with an opening bracket, closing bracket, right? So then the value of p is equal to 1 because p is storing the consecutive occurrences of the character. Previously it was opening bracket. We are placing an opening bracket. Now we have decided to place a closing bracket, right? So we placed a different character than the previous one, right? And what is the constraint for this? So if p is greater than k, then also I will return 0. So what does it mean? So it was mentioned in the problem statement that yeah, the maximum length of the substring of the string containing the same characters not more than k times, right? So if the same characters is become greater than k, then it's an invalid string, so return 0. So these are the few cases that you need to figure out, and rest is just implementation. Just simply write a recursive code and optimize it using our dynamic programming. So here I am using a memo array because what are the states? Okay, let's just first see what are the things that I need to keep track. So the very first thing, index, right? A very straightforward. And then count. This cn variable will store the consecutive occurrences of the characters. Then this p, yeah. So this cn variable will store this thing, whether the string is invalid or not. This thing, this one. So as per my implementation, I have this cn variable is denoting the count of the opening bracket that I have placed so far. And then here I have my p. So what is the variable p? So yeah, this one, same as the implementation. And then last, what does it mean by the last? So basically when I replace this character, when I replace this character, I need to know what is when I replace this question mark, I need to know what is the last character that I have placed, right? So with the help of this, we either increment the value of p or will update the value of p to 1. So then I'm checking if everything so far is fine and index become greater than or equal to n and the value of cn is equal to 0, right? Then and the value of p is less than or equal to k. Basically an happy case. So we got one valid string, so we'll return 1 here. Otherwise we are checking if index is greater than n or the value of p becomes greater than k or the cn value of cn becomes greater than 0. That means we are leading to invalid string, so we'll return 0. Otherwise we check whether we have already calculated this state or not. Then if already calculated, then return the answer. Otherwise this x is storing the answer of the current state, so initializing x with 0. Then I am checking if the current character is question mark, then only I can replace it, right? So yeah, then I'm checking if it is equal to the last character. Then what does it mean? It mean we have decided to place a character. So if it is not equal to question mark, right? Then what does it mean? If it is not equal to question mark, then it means we are restricted to move with this character, right? And if it is equal to the last character, then we'll make a call for recursive call for index for the next index, and the value of cn will incremented by 1 because the current character is equal to the last one, and the last will remain as it is, and the value of p will also incremented by 1, right? Because for opening bracket we have incremented the value of p, and for closing bracket we have decremented the value of p, not p but this cnt, right? Otherwise if it was a closing bracket, then we'll decrement the value of cn and increment the value of p because p is storing the consecutive occurrence of the character, and the last will remain as it is because we have already checked this thing. The current character is equal to the last one. Otherwise we'll do the same thing, right, with the different transitions for the case when the current character is not equal to the last one, and if the current character is equal to the question mark, then I have an option either place the opening bracket or place the closing bracket. So we'll check for the last. If the last is equal to 0, then what does it mean? So it means the last character that I have placed is a opening bracket, and yeah. So then we'll increment the value of cn and we'll increment the value of p plus 1. right? And the last would remain as it is. Otherwise, we have decided to place a closing bracket. So we'll decrement the value of Cn and the count. The value of P will now updated as 1 and we'll change this last. We'll last change this last to 1, right? Basically here in my implementation, the variable last is equal to 0. Last is equal to 0, denoting that previously I had placed opening bracket, and if the variable last is equal to 1, then it means the last character that I have placed is an closing bracket. So don't get confused for this. And then here are the transitions, then taking the mod because answer can be very large, so that's why it's necessary to take a mod with a 10e9 plus 7 1e9 plus 7, which is 10 power 9 plus 7, and then storing this answer and then returning this answer. And from the main function I will make a call for index 0, from index 0 then value of cn, right, the consecutive characters 0, and the value of p, basically the value of cn is equal to 0 and the value of p is also equal to 0 and the last character is also equal to 0. So now let me just quickly try to submit this. And what is the time complexity? The time complexity is the number of different states. What are the things that I have memorized? So index and then cn and p and then last. So this is the time complexity, the number of different states. So the time complexity is the size of this memo. So it is n, the number of different possibilities for index. Then we have another variable cn. So what is the value of cn? Can be, what are the possible values of cn? So cn is basically storing the consecutive occurrences, right? So cn is basically storing the whether the string is valid or not. So it can be up to n, right? So n into n and multiplied by the value of k. So value of p, and at any moment when p become greater than k, then I am returning 0, right? So it can be not more than, the value of p can be not more than k plus 1, right? Or in the, you can write k here because we are considering the big O notation, and then multiplied by last. What are the possible values of last? So possible value of last is only 2 because for 0 opening bracket and for 1 closing bracket, so only two possible values of last, so it is 2. So this is the time complexity, n square into k, 2 into n square into k, right? So hope it is clear to everyone. So in case if you're having any doubt, then let me know in the chat, otherwise we can wrap this session. Can't be done by using only two state, the index and the last? No. And if at the end we can check whether the string is valid or not. So how you can check at the end whether the string is valid or not? So for that thing you have to store, right? You have to store the entire string. But we are not interested that what the string is. We are only interested whether the we are leading to the some valid string or not. We are not interested that what, in that case you have to pass the entire string to the recursive function to check at the end, and that would be take much time. You can also write your code in the solution, will definitely evaluate your mistakes. Any doubt? Write a plus one, minus one, anything. Can we use a backtracking? No, the time complexity for the backtracking is very huge. It is more than the exponential. So it is n power n in some cases, right? And for this problem also, the time complexity would be n power n, which is very huge. You cannot you cannot pass that time complexity solution. That would not work here. It's a pretty standard problem of our dynamic programming. You can draw the recursive tree and you will realize that the problem is having overlapping subproblems and can be memorized using a dynamic programming, DP or a memo vector or array. So yeah, I guess this was all about this session. Thank you so much guys for joining the session. Have a good day.